So what is the #1 mistake people make when they're trying to learn recursion? If you've ever felt like your brain is just tying itself in knots trying to get it, you're definitely not alone. But what if I told you there's just one simple mental shift that can make it all finally click? Well, it's this. They focus on making the input smaller. Look, we're all taught that recursion is about breaking a big problem into smaller and smaller pieces, right? And that's part of it, sure. But focusing only on the shrinking input, that's kind of like trying to understand a great story by just looking at the page numbers. It's a side effect, you see, not the main plot. So, what's the real secret then? It's actually this. It's all about making decisions. That's it. You make one choice, and that choice naturally leaves you with a slightly smaller version of the exact same problem. The smaller input, that's just the result of your decision. It was never the goal to begin with. Okay, let's make this real. Forget code for a second. Let's use an everyday example. Let's say your big problem is, I need to get a good job. Okay, so you make a decision. I'll go to a good college. And boom, just like that, you've created a new, smaller problem for yourself. Now I need to ace my coding classes. See what happened? You didn't directly try to shrink the get a job problem. No, you made a choice, and the problem just evolved. All right, okay, why is this way of thinking so important when it comes to programming? What's the big deal? Well, it's because once you start seeing recursion as just a series of choices, you'll literally start to see it everywhere.
And I'm not kidding. This isn't some obscure concept you'll use once and then forget about. No way. Recursion is the absolute backbone of data structures like trees. The entire structure is recursive. Every node is just a smaller version of the whole tree. It's what powers advanced algorithms like backtracking, which is, when you think about it, all about making a choice, exploring what happens, and then, backing up and undoing that choice if it's a dead end. Seriously, mastering this is so key for interviews and for solving really interesting problems.
Okay, I get it. It's important. But how do you actually spot a problem where you can use recursion? Like, how do you look at something and go, aha, recursion is the answer here?
Well, it really all comes down to this one simple definition. A problem is recursive if you can make a choice, and that choice leaves you with a slightly simpler version of the exact same problem. It's like those Russian nesting dolls, You open one up, and what's inside? A smaller, identical doll. You do it again and again. That's the feeling you're looking for.
All right, theory's great, but let's see how this actually works. Let's draw a decision tree. We're going to tackle a classic problem, finding all the possible subsets of the string A, B, C. And trust me, the best way to wrap your head around the choices we have to make is to actually draw it out. Think of it like a map of all the possible paths we can take.
So to build this tree, we're going to use a really simple but super powerful method. All you need to do is, at every single step, just keep track of two things. First, the input. That's just the characters you have left to choose from. And second, the output, which is the current subset you've built up so far. That's it, input and output.
Okay, so let's start at the very top, the root of the tree. This is us at the beginning of the journey. We haven't made any decisions at all. So, what's our input? The full string, ABC. And our output? Well, it's just an empty string for now.
Now let's look at the very first character, A. We have a really simple choice to make here. We can either include A in our subset or not. That's it, just two possible paths to go down.
And this right here, this is where the magic happens. Watch. If we decide not to take A, what's our new situation? Well, the input we have left is BC, and our output is still empty. But if we do decide to take A, the input we have left is still BC, but now our output is A. Do you see that? We made one decision, and now we have two smaller but identical problems to solve.
And from this point on, it's basically just rinse and repeat. We just do the same thing again. For each of these two new branches we just made, we're going to face the exact same kind of decision, but this time it's about the character B.
Let's just follow the paths down. So, on that left branch where our output was empty, we now have a choice. Don't take B or take B. And on the right branch where our output was already A, we do the exact same thing. Don't take B or take B. And just like that, our two branches have become 4 new branches. And for all of them, the only input left is C.
We're almost there. We're at the finish line. For every single one of those 4 branches, we do the same thing just one last time. Now for the character C. You guessed it. We either include it or we don't.
Okay, so after we've made our final choice about C, guess what happens to our input string? For every single path, it becomes empty. And that is our base case. That's the signal to stop making decisions. The output that we're left with at the very end of each path, well, that's one of our complete subsets. And look at that. There they are, all 8 possible subsets of A, B, C. Now here's the most crucial point of this whole thing, so really listen to this. If you can draw this tree, you're like 90% of the way there. You've already done the hard part. You have solved the logic of the problem. The rest, that's just translating what you drew into code.
So this brings us to a super simple 2-step method you can use for pretty much any recursive problem. Step 1, forget about the code completely. Seriously, just focus on designing the decision tree. Ask yourself, what are my choices? How does each choice change the problem? And then, step 2, only once your tree makes sense and it's solid, then you can go ahead and translate that beautiful logic into code.
Let's just let this sink in with this one powerful idea. If you can draw the decision tree, writing the code is the easy part. It really is. So stop wrestling with base cases and recursive calls inside your head. Just focus on the choices. Draw the tree. The code, it'll just follow.
So what's the big takeaway here? It's that recursion isn't some scary, complex monster. It's really just a way of exploring choices one step at a time. So now that you have this new way of looking at it, this new lens, what problem are you going to go solve first?